Two and a Half Admins, episode 97. I'm Joe.
I'm Jim.
And I'm Alan.
And here we are again. And before we get started, another plug for your ZFS developer job, Alan.
Yeah, so we're looking for more people to join our team to work on ZFS and make it better. It's fully remote, working with a great team of other people who love ZFS as well. So if you're interested, get in touch via the link in the show notes.
All right, and another plug for your webinar.
Jim and I will be doing a webinar about how to get started with Beehive, the FreeBSD hypervisor, on July 12th at 1 p.m. Eastern.
Right, well, link to that as well in the show notes then. I saw some discussion recently about the best way to test your internet speed. And speedtest.net has been around for an awfully long time, and fast.com, which is Netflix's speed test site, I see get recommended. But surely these amateur hour sites can't be the most convenient and good way to test your internet. So I thought I'd ask the expert. So what would you recommend?
I think they're probably still the most convenient. But if you're really wanting to dig into it, there are some other tools you can use to get more information. The one I use the most is called Iperf. It's available in all the package things. Be careful, there's Iperf 2 and Iperf 3.
And you want Iperf 3.
Yeah. Iperf 2 is different. Like it still has some uses. If you do multiple connections, it uses separate processes and spreads the load over the CPU differently. But yeah, in almost all cases, you want Iperf 3 anyway. And so in the show notes, I plopped a website that has a list of public Iperf servers. So Iperf is a little command line app, and you tell it a server, and it will connect to it and upload to it as fast as it can. And then I think there's a switch to make it do a download instead, or the other side can push to you and so on. So it's also can be useful if you have two specific hosts and you want to speed test between those two hosts, right? When you go to speedtest.net, some random server happens to be close to you, or oftentimes it's at your ISP. It's like, well, I know my speed to my ISP is good. I want to know what's my speed between here and my Linode device. So being able to actually run it between any 2 points I want and actually do a speed test, and it'll print out stats and tell you about how many packets had to be retransmitted and what the latency was and how the sliding window in TCP acted and so on, and can really help explain what is going on with the performance.
Most people want a simple, I do this one thing and I know how fast my internet is. And unfortunately, it isn't that simple. That there is no simple answer like that you can have. Because you can have issues between yourself and, the next hop, meaning the immediate gateway to the ISP. You can have problems at the ISP's immediate peering point out to the major backbones. You can have a problem in one of those backbones. You can simply have routes that are ridiculously too long, from your ISP, but they would not be with the competing ISP in town. And those ridiculously long routes, they may only be to one particular site that you care about that don't affect the rest of your internet experience. So I think I just want the simple answer, I would recommend Netflix's fast.com. It's much quicker than most of the speed test sites. I have yet to encounter an issue where Netflix, their test server didn't have enough bandwidth, which is also a problem you can absolutely encounter when using these public speed test sites. When you see a low speed, the question is, does it have anything to do with my ISP at all? That whole long chain of things I just described. Well, there's also the potential issue that whatever that test server is happens to be overloaded right then. And that's the bottleneck in that particular thing. So if you really want like a comprehensive picture, you're going to need to test between yourself and several sites. And ideally, you kind of want to have a pretty good idea of, which geographic regions you care about. You want to have an idea about latency versus throughput, which is another thing that, gets really impacted by having too many hops between yourself and another site. There are a lot of issues that don't necessarily show up in just a throughput test. So for that reason, one of my favorite test sites over the years has been the DSL Reports speed test. They give you a lot more information about, buffer bloat on your end, latency issues, yada, yada, yada. Unfortunately, it seems like maybe it hasn't been updated very well recently. I've had some problems with the interface in modern browsers lately. So I'm not sure how well maintained that is anymore, which makes me sad.
Yeah, that was a very useful resource for quite a long time. I guess it's not really speed testing, but another tool I really like is MTR, or Match Trace Route. It's basically an ongoing traceroute that's a lot snappier than regular traceroute. And it really lets you see how the traffic is flowing to you, what the changes in the latency are like between hops, and can really elucidate what's happening, why it seems weird between here and there. But of course, if you have access to the points at both ends and you can do MTR in both directions, the other thing you'll notice is that often they take very different paths in each direction. Like sometimes not even going over the same internet backbones to get to there, because it depends who buys who bandwidth from whom and who peers with whom and so on. And it can be really interesting, when you see on your trace route that after this hop, the latency jumps way up. And it doesn't really seem to be explained, but you look in the trace route on the other side and you can see it goes all the way from Chicago to like Arizona and then loops back up around for some reason and weird things like that. And MTR can also make it more obvious when you see things where there are like 4 different routers for the same hop and know that the traffic is actually being hashed across like 4 separate 100 gigabit links. And I've even seen a weird thing one time where one of those 4 or 6 links was bad. And so if I was doing a speed test between the host A and B, it'd be fast. But if I did a different port number, it would be slow based on which of the 4 links it ended up going across. And if you picked one that happened to randomly hash out to the bad link, then you would get worse performance on every 4th port, basically.
Yeah, for those of you who are familiar with running trace routes on the command line, but who have not used MTR, the best off-the-cuff idea I can give you here is imagine a trace route, only it gets to the other end about like 5 or 6 times faster than the traceroute command does typically. And also it's continuously updated and you can actually see changes in the quality of each one of the links along the way as you keep it open, which is great because sometimes you'll run one traceroute and either you get the one magically bad traceroute that had, a problem just that one time, but normally everything's fine, or you run the one magically good traceroute on a really crappy connection. And with MTR, you set it up and the default mode is going to be interactive and it will stay up for as long as you want it to. And it will report, percentages and averages for every link down the chain. It's a great diagnostic tool.
Yeah. Picture traceroute combined with top. So yeah, really useful for figuring out what's going on. But Iperf is really nice, especially if you have access to a bunch of hops along the way. Like doing an Iperf between my machine and the OpenSense router. And then between that and something that happens to be really nearby. And then, like I mentioned, if you rent a VPS somewhere and you're wondering what's your speed to that VPS, being able to test that by using Iperf is really handy.
And I will say also, if you're somebody who is shopping around for a VPS and you're not sure what provider you want to use and you have... Especially when it's something that like you want to set up a website that a lot of people will use or some other resource that needs to be effective to multiple geographic regions. One of the better ways you can distinguish between your providers, not necessarily just VPS, like any data centers anywhere. This also works for multiple data centers at one particular provider. When you want to do an evaluation of a bunch of networks and figure out which one do I want to land on, just go ahead and rent like a $5 instance at all of them that you're considering and run MTRs to test servers in each of the geographic regions that you're worried about serving and look at how long the route is to each of them. You'll find very quickly that, one provider maybe has like, there's only 4 hops in between, them and like Google and, another one like, holy crap, there's like 16. And when you compare it with like your home internet connection, again, like if you're in a proper data center, even a cheap one, you should see trace routes to public resources that are a lot shorter than the ones that you run from your home internet connection. If you don't see shorter trace routes or, MTR paths, whatever, then that's maybe a sign that you should keep shopping.
One interesting thing that doing these MTRs can show you is some ISPs will do what's called cold potato routing. They won't get the packet off their network until it's as close to the destination as they can. They try to use their network to haul it as far as possible. And other ones will do kind of basically the opposite, like hot potato. It's like as soon as we can find somebody else who will take this traffic, we're going to give it to them and let them haul it. And some of them, I think it was Frontier or something, tried to do cold potato, but their network is crap. If they just handed it off, it'd be fine, but they're just hauling it all the way to the East Coast for you on their crappy network.
The last mile ISP to your house, almost all of them do that. They will go a long distance on their own very crappy backbone before they hit a peering point because they're trying to minimize their own costs.
Let's do some feedback then. Mike writes, while you talked about memory limits against file system cache thrashing for VMs in particular, and how Arc handles this better, you also mentioned how this problem extends to apps that do large file system scans like backups. I think it might have also been worth a mention that modern Linux also has a solution for that, and a somewhat similar one to resource limits on VMs, C groups, which are used by default on almost all modern distros as an integral part of systemd. Limits like memory max equals 256M in any unit file, including one-shot files for .timers, count file system cache memory as well. And for running things outside systemd, like from cron, there's systemd run, which can be used to create a transient .scope or .service with any kind of limits like these. One might be tempted to call such things containers, but that's not really the same thing, and might be misleading, as a defining feature of containers is using Linux namespaces for isolation, not just resource and bandwidth limits.
I wasn't aware that those cgroup limits would apply to the file system cache, because usually the file system cache isn't owned by any one process, right? If two different processes are both reading the same file repeatedly, causing it to be in the file system cache, which process does that file get charged against the memory limit for? And then if the buffer cache isn't included in the memory limit for the application, which I expect it shouldn't be, then again, it is basically the same thing as what we're saying. You limit the application so they can't use a lot of memory, and then you have the buffer cache in the OS do the heavy lifting of deciding globally across all your applications which files should be cached to get the most value. I think the bigger example thing is something like MariaDB or MySQL or Postgres or whatever. That's probably going to have its own, allocate a big block of memory and try to keep its own cache of what's the most popular. And it has more insight than the file system does about, these are rows rather than just blocks of data in a file. But at some point, the kind of global view might actually give you the better ability to decide what's important. Because, MySQL can't decide, oh, I'm not using most of my cache right now and this other application needs it, whereas the buffer cache can decide to do things like that.
Yeah, I'm also not certain of Mike's conclusions here. If we look at the documentation for memory controller and C group and memory current, memory high, memory max, there's no mention made of them limiting the kernel page cache, which is where the file system cache actually lives on Linux. It lives in the kernel page cache, along with the rest of pages that the kernel would like to cache. While it would certainly be possible to implement something that limited how much an application could contribute to the kernel page cache, I don't see any indication in the docs here that that's what memory.max is actually doing. It could be a useful feature if implemented, and maybe it already is, and I'm just not seeing it in the documentation. But the other thing I'd like to point out is that I would push back against calling that a solution in the way that the Arc is. It's a mitigation. Assuming such a feature exists and you can forcibly put hard limits on how much an application's I/O can contribute to, file system cache in the kernel page cache, that might very well be a useful thing you'd want to do and say, hey, I'm going to, make sure that my backup utility can't just dump its entire stream of data that it reads into the kernel page cache, and that would be useful in the absence of something like an Arc. But it's a mitigation, not a solution. You're still talking about a cache that's not that bright and accepts absolutely everything dumped into it. And now you're just saying, well, in order to work around that, we'll try to limit how much we're allowed to contribute to it.
Yeah, and I think including the file system cache in things like memory max would be very confusing, because the whole point of the file system cache is this is data that we could always throw away in order to get more free memory if we needed it. So should that really count against the program's memory limit? Since it's not actually memory that's in use. It's memory that's basically been freed, but we're keeping the content around because we might use it again, and that would be an optimization over having to, go and read the data from disk again. But yeah, to Jim's point, the problem with the Linux page cache is that it's a dumb LRU, and it's always going to have its content thrashed by something like a backup. And you could run your backup with the flag to make it not use the buffer cache or whatever, but that just makes your backup slower.
I've been reading more documentation as Alan talked, and I'm going to get a little bit stronger on that. I do not believe that Mike is correct about that. Looking at the docs for this at freedesktop.org, memory max equals bytes, specify the absolute limit on memory usage of the executed processes in this unit, which that's not where the file system cache lives. It doesn't live inside that application's memory space. It lives in the kernel memory space. So I don't believe this setting does what Mike believes it does.
Okay, Jonas writes, as a Linux user on a Windows desktop, finding this project gave me a lot of joy. And then he links to OpenZFS on Windows. He says, the README says it's OpenZFS for Linux, but the releases page has Windows binaries. I'm planning to try ZFS send, Sanoid, and redirecting my documents, downloads, pictures, etc. directories. Excited to see if this will be my first buggy ZFS experience. I'd love to hear your experiences or thoughts.
So the reason it says ZFS on Linux there is because it's a fork of the older OpenZFS repo. So OpenZFS on Windows has been around for a while. I think it was called something slightly different in an older version, but they rebased it when OpenZFS 2.0 happened, and it merged in support for FreeBSD, and support for macOS and Windows is eventually destined to end up in that same repo. So it's basically got feature parity with ZFS on Linux and FreeBSD. I think a bunch of the debugging stuff is still on, so that when something goes wrong with Windows, you get more information that you could give the developer to help them fix it.
Which also means expect a bit lower performance because of all the debugging stuff that's still turned on.
I remember when Jorgen showed up at the OpenZFS Developer Summit and showed off doing a send receive from Windows and it working. And we were all like, wow, you are a madman for just trying to take that on. But he did it, and it works quite well. And I know of some companies actually using this in production for embedded things that have to run Windows. And they wanted a file system that wouldn't just curdle itself if it unexpectedly rebooted.
Okay, this episode is sponsored by Linode. Go to linode.com/25A, support the show, and get $100 free credit. From their award-winning support, offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. And check out their managed MySQL, Postgres, and MongoDB databases that allow you to quickly deploy a new database and defer management tasks like configuration, managing high availability, disaster recovery, backups, and data replication. Simple and fast to deploy with secure access, their flexible plans include daily backups. So go to linode.com/25A, create a free account, and you get $100 in credit and support the show. That's linode.com/25A. Let's do some free consulting then. But first, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. You can go to 2.5admins.com/support to learn more. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send any questions for Jim and Alan or your feedback, you can email show@2.5admins.com. So Ricky writes, I work for a medium-sized, cost-conscious startup. We're basically a remote monitoring and control company, so every week we're provisioning and installing new hardware at new locations. I'd like to roll out a network monitoring system for our deployed hardware. I took a pass at using Nagios for this. While it does work, every time we add a new node to our network, I basically have to scrape our database of hardware and regenerate the Nagios config files using some templates I've developed. Ideally, when a new device is added to our database, it would automatically get injected into the NMS system. Nagios doesn't feel like the best fit for this. As I have it set up now, I could configure a cron job to regenerate the config files and reload or re-hop Nagios. However, it seems like a better fit would be an NMS that exposes an API allowing dynamic changes to inventory. I'm aware of other NMSs like Zabbix, but there's so many moving parts and subsystems. Maybe Sensu and Libre NMS are also options. The list of things I'd like would be API exposed to allow dynamic inventory changes, ability to horizontally scale polling and checks, as simple setup as possible. I'd like to use SSH for UP checks, and SNMP for any additional detail to be fetched from the hardware. Running a local agent is not required. Free as in beer, although ideally free as in speech as well. Whatever solution is chosen will ultimately run in AWS, hence the desire for horizontal rather than vertical scalability. I'm not totally opposed to using Nagios. It works okay so far. I just feel like there's a more optimal solution for the use case I've outlined.
It depends a bit on how you do it. Like in my setup, we use Nagios and Puppet. And so when the new node gets deployed, it runs the Puppet agent and it registers itself in the Puppet master. And then the Puppet running in the Nagios jail pulls down that information and writes out a new config file. So we basically have a .d directory called like servers.d, and each server gets a file added to there based on the template and says, here's a new server, and it has services A, B, and C, and this one has B, C, and D, or whatever, and then it all just shows up in Nagios and works. And so as soon as a new machine shows up, the next time Puppet runs on Nagios, 20 minutes later, that machine pops up in Nagios and starts working. And it automatically cleans them up when we decommission a machine.
The challenge to automating Nagios, I think, is greatly overstated here. It's certainly not hard to have a template and to just fill it out with the couple of details you need for any particular new node as you deploy it, pop it in, and hup the Nagios daemon. It's not hard at all. As far as what Alan was saying about organization, I do the same thing, possibly to an even greater degree, because under my Nagios.d folder, I've got folders for each client of mine. Like, each client is self-contained in its own folder. All of their infrastructure is in there. I've got templates for types of servers. Like, there's a Sanoid server template. There's an Ubuntu server template. I don't use it anymore, but there's still a FreeBSD server template, on and on down the line. With that said, I don't think Zabbix is going to be a good fit for Ricky, but Libre NMS certainly could. Now, one of the big design goals that really matches up there is the scalability. Scaling out to tens of thousands of nodes is one of Libre NMS's biggest selling points. Automatic network discovery is another one of Libre NMS's big selling points. Now, Libre NMS does not work for me because the last thing I want is automatic discovery. There's all kinds of things on all the networks that I monitor that I frankly don't give a crap about. I do not ever want to find myself getting an alert because somebody brought an iPhone into work and then went home with it. Now the iPhone's not there anymore, and I'm getting an alert because the device went missing. It's not what I want. However, with that said, some of the details that Ricky gave us, it sounds like his company very specifically wants to monitor a limited set of devices that could be identified via the SNMP polling. And so you could tell Libre NMS, this kind of device is all I care about. If you see one of these, I want you to add it to the database. I want you to monitor it. I want you to alert me. I want to do all those things. But if you see just some generic PC or server or phone or whatever, it's not my problem. I don't care. Now, the one place I think that Libre NMS really falls down with what Ricky has asked for is the simple setup part. I don't know, the Libre NMS folks, very nice folks, they might argue with me on this and say, oh no, it's totally simple. I do not find it simple. It's a lot like GNU Cache in the sense that it doesn't really come across as a ready-to-use application, in my opinion, so much as like, okay, this is a platform that you can develop your application on and using. There's a lot of setup and needing to understand the architecture and what you're doing. And to be fair, there's some of that with Nagios as well, but I feel like the complexity level scales considerably up for Libre NMS from Nagios there.
I think Nagios is probably still the right answer here, although it might struggle to scale horizontally to that many, although you can chart it a bit.
As much of a fan of Nagios as I am, I think I'm going to pitch Libre NMS for this, because I think it sounds like Ricky's company really wants to grow and get big. And if it really wants to grow and get big and monitor all of its client stuff from one platform, I don't think Nagios is the answer for that. Nagios is a great answer for, I have critical core infrastructure that I want to monitor. A few thousand devices, sure, but like there's a given scale and you care a little bit more about, each device and how you monitor it. Whereas Libre NMS, I think, is really going to lend itself to what he wants, which is automate it as much as possible, pick things up with as little human interaction required as possible, and scale absolutely massively. And that's what Libre NMS was designed for.
I built something kind of similar to how we do it for Nagios, except for without using Puppet, where we have an inventory database of all of our machines, and they show up there when they start up, and they remove themselves when they shut down in the cloud and so on, and when we use cloud instances. And we use it to generate our DNS zone files. So it's like, oh, here's a list of all the servers, and we know what services they have. And so we can make a pool saying all the machines that have this service, break them down by region and fill these DNS buckets for our load balancer. And it just runs every so often. It writes out the new zone to a temporary file and checks the syntax and makes sure it's not broken so it doesn't put a broken file in place and that kind of stuff. And you could do that here too. But yeah, if you want it to just scan and find stuff, like Jim said, Libre NMS might be a much easier option.
My Nagios configs actually are They are the bottom level source of truth for all of the stuff that I care about. If I care about it, it's in my Nagios. And if it's in my Nagios, it is correct to the point of being reachable, because if it isn't, my phone is blowing up in my pocket and pissing me off, and I'm fixing it now. So the ultimate source of truth in my distributed network, it is the Nagios config.
My Nagios configs are much lighter. Like each individual host contains probably no more than 10 or 15 lines. It knows a little bit, here's the host name and some IP addresses or whatever. Sometimes it has a little bit of information about where the IPMI for that device is, so it can check the power supplies and things like that. So it sets a couple of custom variables and a list of services, and that's it. And then all the stuff it cares about is defined in the service configs, which are more static. And if you have this service, you have to do all of these things.
Yep, service configs and host templates, same here. I have a host name, I have an IP address, which usually actually the IP address line, it's just the host name all over again. Because there's like a human readable host name, and there's how you actually go to reach the device. And you can use raw IP addresses for that. But as I've covered before on the show, I don't do that. I use private DNS zone files. So Sanoid machine 1.client2.wg, like that is the name of the machine. You can ping it by that name. That, along with what host template to use, that's pretty much all you get. The service templates don't even show up in my host configs, because the service templates are attached to the host templates. So all I really have to say is this is a Sanoid server, and all my things are set up for it. I'm going to get snapshot freshness monitoring. I'm going to get pool health monitoring. I'm going to get free space monitoring on all mounted file systems on that device. I'm going to get RAM usage monitoring. I'm going to get load monitoring. I mean, I could go on. It's a lot of things. But the point is you define it once in that class of device, and it all goes from there.
Yeah, we take ours a little bit differently, partly because we treat Linux and FreeBSD hosts the same in a lot of ways. And so it's like, this server does video streaming, then it'll have this software and do this, and we need to monitor that. And then if it's a storage server, then we monitor, it has certain checks, make sure that all the data sets are mounted. And if it's a backup server, it checks that the snapshots aren't too old. If the oldest snapshot in this data set is more than 30 minutes old, then replication's delayed. Keep an eye on that. And if it gets to be 2 hours, then somebody's phone needs to start chirping.
The other thing I'll mention for those of you who have not used Nagios in anger is, when I talk about these great host templates, you're not limited to just one per host either. So you can define it as like a whole role kind of a thing. And as a matter of fact, in my situation, I have a fairly standard infrastructure type. So the Sanoid server template in my setup actually has the Linux server template as a dependency. It's implied. So you define the things you want to do to all Linux servers. That gets pulled in automatically with the Sanoid servers because they are defined as Linux servers, and on down the line. So, but you can also do it that way in the individual hosts. So if you're like, well, I've got Linux servers and I've got video servers and I've got storage servers, and any one machine could be any combination of those things, you can actually apply multiple of them to a single host in the host config. And again, you've got kind of your single source of truth here, because you look at that host config, you know what its name is, you know how to reach it, you know all the roles that it has.
Right, well, we'd better get out of here then. Remember, show@2.5admins.com if you want to send any questions or your feedback. You can find me on Twitter @Joe Ressington.
I'm on Twitter @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.